Good evening everyone, good evening. I welcome you all again to your Vedantu and NEET channel. I hope you all are doing great, having a good time. So people, quickly let me know in the chats if I am perfectly audible and visible to everyone. Yes, quickly let me know in the chats if I am perfectly audible and visible to every one of you, right? Let me quickly know, people, in the chats if I am perfectly audible and visible to everyone. Perfect. Just give me a second, we'll be starting, right? Just give me a second, guys. Let me fix the things, we'll be starting. All right, I'm doing great, Nandini, thank you. All right, people, so in the tonight's session, what we are going to talk about will be continuing with the Zero to Superhero series, right? And in this session, we are going to do the chapter Redox Reactions, right? So basically, in this particular session, I have come up with around some 30 questions from the chapter Redox Reactions, and I'm sure by solving these questions, your whole chapter will be getting revised properly in lesser time, right? So before starting this particular session, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself, right? So people, my name is Wassim, and I'm your chemistry master teacher writer on this Vedantu and NEET channel, right? Well, the ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this Vedantu and NEET channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, right? So people, you can quickly let me know in the chats if all of you are super duper excited about this particular session as well. Yes? Let me quickly know in the chats if all of you are super duper excited about this particular session as well, right? Let me quickly know in the chats. Let me quickly know in the chats. Perfect, guys. Perfect. So let's get going then without wasting a lot of time. Let's get going. Let's get started with the first question from the chapter Redox Reactions, which is going to be on your screen now. Well, the first question, which is based on the oxidation state, right? As far as this particular question is concerned, we are supposed to calculate the oxidation state of chromium in CrO5, right? Well, you can calculate the oxidation state of chromium by just drawing the structure of CrO5. And let me tell you, this CrO5, it has got a butterfly structure first of all, right? Do remember, it has got a butterfly type structure, right? And do remember, this CrO5, it is deep blue in color. The CrO5 is exactly deep blue in color, right? So what about the structure of this CrO5? This is chromium over here, and there's a double bond. This is oxygen, this is one more oxygen, there is a single bond right here. There are two oxygens, and over here there is one more bond between two oxygens, right? Have a look, people, exactly. Do remember first of all this structure. Do remember this structure, number one. Number two, let's get to know the oxidation state of this chromium in this particular compound, right? See guys, there is a first of all double bond between chromium and oxygen. And we know oxygen is more electronegative than chromium, right? So oxygen is going to drag both the electron pairs towards itself, due to which oxygen gets -2 and chromium at the same time gets +2, right? Similarly, if you talk about this particular bond, this single bond between chromium and oxygen, again chromium being more electronegative will attract the bonded pair of electron towards itself, due to which it will be having -1 and at the same time chromium +1. Similarly, due to this bond, this is going to be -1, this is going to be +1, this is -1, this is +1, and this is -1, this is +1. So calculate the total charge present on the chromium. It's +2, +3, +4, +5, and +6. So basically, the total charge present on chromium is going to be +6. So I must say the oxidation state of chromium in CrO5 is going to be +6, but I cannot find the option as +6. What is it? What just happened to this? It's going to be +6, but right? Okay, so this is going to be +2, +3, see, +2, +3, +4, +5, +6, right? The option is marked as wrong over here, but do remember, it's going to be +6, right? CrO5, right? Okay, do remember, it's going to be +6. Perfect. Let's move on to one more. the oxidation number of sulfur in H2SO5, right? H2SO5, which is what we call as Caro's acid, right? So first thing, what about the structure of H2SO5? You need to know about the structure of H2SO5, then you can easily calculate the oxidation state of sulfur in this particular compound, right? Let me simply draw the structure of H2SO5. There are two double bonds between sulfur and oxygen, right? There's a single bond attached with hydrogen. So till now I've used 1, 2 and 3, 3 oxygen atoms. This is the fourth one, this is the fifth one, and there will be one more hydrogen right here. So this is basically the structure of your H2SO5. Now after drawing the structure of H2SO5, you can easily calculate the oxidation state of sulfur in this particular compound. Check it out. See, if you talk about this particular double bond between sulfur and oxygen, which one is more electronegative? I must say oxygen, right? So oxygen is going to attract both the bonded pair of electrons towards itself, due to which it gets -2, and sulfur at the same time gets +2. Similarly, this gets -2, this gets +2. Similarly, this gets -1, this is +1. And this is going to be -1, and this is +1. So check it out. What is the oxidation state of sulfur in this particular compound? What is the total charge present on sulfur? 2, 4, 5, 6. So +6 is the oxidation state of sulfur in H2SO5, which you guys will be remembering from now onwards. Do remember, there is one peroxide linkage between two oxygen atoms in case of H2SO5. Do remember this, right? This is going to be its structure. Perfect. I would want you guys to remember its structure, right? This is H2SO5. Moving on to one more. The average oxidation number of sulfur in H2S2O8, right? H2S2O8, which is something which you call as Marshall's acid. I hope you know it. H2S2O8, right? So first thing, you again need to draw the structure of H2S2O8, then only you can solve this particular question. This again simple. See guys, this is S double bond O, this is one more double bond, this is oxygen attached with hydrogen. So till now I have used 3 oxygen atoms, right? So there is one oxygen here, and this is S double bond O, this oxygen attached with hydrogen. This is the structure of your H2, S2 and O8, right? Now you need to basically calculate the average oxidation state of sulfur in this particular compound, right? You need to calculate the average oxidation state of sulfur. So in order to calculate the average oxidation state of sulfur, I will be first of all calculating the oxidation state of this particular sulfur, then this one, then I'll be calculating their average, right? Now we will have a look exactly how am I going to do it. See, there is a double bond between sulfur and oxygen, right? So oxygen is more electronegative. It's going to attract both the bonded pair of electrons towards itself, due to which it gets -2, and at the same time sulfur gets +2. Again, this is going to be -2, this is going to be +2. This is going to be -1, this is going to be +1. Similarly, this is going to be -1, this is going to be +1. So what about the total charge present on this particular sulfur? You can check it out. It's going to be +6, right? Similarly, the oxidation state of this particular sulfur is going to be +6. So if I would want you guys to calculate the average oxidation state of sulfur, you'll say average oxidation state of sulfur is going to be, have a look. The charge present on this particular sulfur is +6. The charge present on this particular sulfur is again +6. There are total 2 sulfur atoms, so divide by 2, the total charge comes out to be +6. So +6 is again the average oxidation state of sulfur in case of your H2S2O8. I'm sure this is again clear to everyone, right? Perfect, guys. Moving on to one more. The oxidation number of calcium. This is calcium over here. This is not carbon, okay? The oxidation number of calcium in CaOCl2. Well, first thing, you just need to remember the structure of your CaOCl2, right? Okay, so this calcium, this oxygen attached with chlorine, right? And this is one chlorine directly attached over here. This is the structure of your CaOCl2, right? Now people have a look. If you particularly talk about this particular bond between calcium and chlorine, I must say chlorine is more electronegative, so it's going to attract both the bond. It's going to attract this bonded pair of electron towards itself, due to which it gets -1, and calcium at the same time gets +1. Similarly, due to this single bond, oxygen will get -1, calcium will get +1. Due to this single bond, oxygen being more electronegative, -1 and +1. So what is the total charge present on this calcium over here? So I must say it's +2. So the oxidation state of calcium over here is going to be +2, right? Similarly, if I ask you, what about the oxidation state of this chlorine? This chlorine is going to be having -1, and this chlorine has got the oxidation state of +1, and this oxygen, it has got the oxidation state of -2. You can check it out. -1 comes out to be -2, right? Now, if I ask you what about the average oxidation state of chlorine in this compound? Average oxidation state of chlorine, if I need to calculate, for example, it's simply going to be equal to charge present on this chlorine, that's +1. Charge present on this chlorine, that is -1, divided by how many chlorine atoms? 2. So the average oxidation state of chlorine comes out to be 0. I'm sure you guys know it already, right? So I'm sure this question is again clear to you. Let me move on to one more. The oxidation number of, this is BA, this is not B. I don't know why there are some mistakes in these slides. This is BA over here. The oxidation number of BA in BASCN whole twice. Well, in order to answer this particular question, you should know the structure of BASCN whole twice, right? So let me quickly show you the structure of BASCN whole twice. This is BASCN whole twice, right? So let's get to know exactly the oxidation state of every element over here, right? So what I'll be doing over here exactly, I'll be starting with this particular triple bond between carbon and nitrogen. If I ask you, among carbon and nitrogen, which one is more electronegative? You must say it's going to be nitrogen, which is going to be more electronegative, right? So nitrogen is going to attract all the three bonded pair of electrons towards itself, due to which nitrogen gets -3 and carbon gets +3, right? Similarly, due to this triple bond, nitrogen gets -3, carbon gets +3, right? Among carbon and sulfur, which one is more electronegative? It's going to be sulfur. So sulfur is going to attract this particular bonded pair towards itself. So -1 at the same time, this is +1. So this -1 at the same time, this is +1, right? Now check this particular bond between barium and sulfur. Sulfur is more electronegative. Again, it will attract the bonded pair of electron towards itself. So it's going to be -1 again. This is going to be +1. Similarly, due to this particular bond, it's going to be -1 and +1. Check the total charge present on this barium right here. It's going to be +2, right? So the oxidation state of barium right here is +2. Whatever the oxidation state of sulfur, it's -1 comes out to be -2. Check out the oxidation state of this particular carbon. It's going to be +3 +1, that is +4. Check out the oxidation state of this particular nitrogen. It's -3, right? Similarly, this is -3. This one is +4, and at the same time, this one is going to be -2. So you calculated the oxidation state of each element in case of your BASCN whole twice, right? So I'm sure your question is done and dusted. I was supposed to calculate the oxidation number of barium over here, so it is coming out to be +2, as simple as that, right? Perfect, guys. So let's move on to one more question. The oxidation number of chromium in K3CrO8. Well, first thing, how do you draw the structure of your K3CrO8? Let me show it to you. Have a look. This is chromium right here. This is oxygen. This is one more oxygen. And these two are attached by means of a single bond. This is oxygen. This is one more oxygen. This is one more oxygen, right? Again, a peroxide linkage, peroxide linkage, peroxide linkage. This is potassium. This is potassium attached. And this is again one more potassium attached, right? So this is basically the structure of your K3CrO8, right? Now you need to calculate the oxidation state of this chromium right here and how you are going to do it. Have a look exactly. Have a look exactly, people. See, if you talk about this particular single bond between chromium and oxygen, I must say oxygen is more electronegative. So oxygen will attract this bonded pair of electron towards itself, due to which it gets -1 and chromium gets +1. Due to this particular single bond, again oxygen -1, chromium +1. Due to this single bond, -1 and +1. Due to this single bond, -1 and +1. Due to this single bond, -1 and +1. Check the total charge present on chromium right here. It's 1, 2, 3, 4, 5. So +5 is basically the oxidation state of chromium in this particular compound, right? Yes? Let me know in the chats if every single thing is clear till here. Right, people? Yes, 2023 students can also join in. Perfect. So +5 is basically the oxidation state of chromium in this particular compound, right? Let's move on and have a look on one more question. This is one more question. We need to calculate the oxidation states of phosphorus in the given structures, right? Well, the structures are given to you. I would suggest you guys to remember all these structures directly, right? Okay, in the exam, they are not going to give you the structures. They'll simply tell you what is the oxidation state of phosphorus in H3PO2, H3PO3, H3PO4, and so on, right? So it's better to remember these structures, right? Now, have a look. If I talk about this particular single bond between phosphorus and oxygen, you know oxygen is more electronegative. So due to this single bond, oxygen -1, phosphorus +1. Due to this double bond, right here, oxygen -2, phosphorus +2. Among phosphorus and hydrogen, I must say phosphorus is more electronegative. So phosphorus is going to attract this bonded pair of electron towards itself, due to which it carries -1, and this is +1, again -1, again this is +1 due to this bond, right? So what is the net charge present on this particular phosphorus? Have a look. +2, +3. +3 -2 comes out to be +1. So +1 is the oxidation state of phosphorus in the first one, right? Now, look at the second one, my dear people. This is P double bond O. Oxygen will carry -2 and this phosphorus will carry +2 due to this double bond, because oxygen being more electronegative, right? Similarly, this is a single bond, so -1 and +1. There is one more single bond, -1 and +1. And now there is a single bond between phosphorus and hydrogen. Phosphorus being more electronegative, so -1 and +1. So what is the net charge present on phosphorus right here? +2, +3, +4, -1 comes out to be +3. So +3 is the oxidation state of phosphorus right here. So +1, +3. Over here +1, +3, right? So I'll take the last one. Let me tell you first of all, phosphorus cannot show the oxidation state of +8, right? Phosphorus cannot show the oxidation state of +8. Phosphorus can show the maximum oxidation state of +5, right? So it's going to be absolutely option A, which is the correct answer of this particular question. Clear to everyone? Clear to everyone? Let me know in the chats. Perfect. The compound that cannot act both as oxidizing and reducing agent. Which of the following compound cannot act both oxidizing and reducing agent? Yeah? Let's have a look. See guys. Well, if you look at this H3PO4, if you talk about the structure of your H3PO4, well, in the structure of H3PO4, you'll get to know that phosphorus over here is having the oxidation state of +5, right? Let me tell you, +5 is the maximum oxidation state that the phosphorus can show, right? If phosphorus has got the maximum oxidation state of +5, so it cannot increase its oxidation state beyond +5, right? If phosphorus cannot increase its oxidation state beyond +5, I must say this H3PO4 won't undergo oxidation. If it does not undergo oxidation, it cannot act as a reducing agent, right? So option C is the one which is going to be the correct answer of this particular question. H3PO4, it cannot behave like the reducing agent, right? Because it cannot undergo oxidation, because already phosphorus over here is present in its highest oxidation state, right? I'm sure this is again clear to you. Perfect. Let me move on to one more. Which of the following can function as an oxidizing agent? Which of the following cannot function as the oxidizing agent? What is an oxidizing agent first of all? Well, let me tell you, oxidizing agent is the one which oxidizes others but itself undergoes reduction. So oxidizing agent itself undergoes reduction, right? If you look at this I negative, over here the oxidation state of iodine is -1, right? Oxidation state of iodine is -1. Well, this is the lowest possible oxidation state of iodine. The lowest possible oxidation state of iodine is -1. It does not show -2, -3. So this iodine over here, this I negative, it cannot undergo reduction. If it cannot undergo reduction, it cannot behave like the oxidizing agent. As simple as that. So I negative is the one which is going to be the correct answer of this particular question. Because iodine over here is already present in its lowest possible oxidation state, right? Perfect. Let me move on to one more question, guys. The compound that can work both as oxidizing as well as a reducing agent. This is something which I would want you guys to remember, right? It's H2O2, right? H2O2 is the one which can act both as oxidizing as well as a reducing agent, right? Okay, do remember H2O2 is the one, because in some reactions H2O2 can get converted into O2, and in some reactions H2O2 get converted into water, right? You can check it out, have a look. Oxygen over here has got the oxygen state of -1 because it's in peroxide linkage. Over here it's 0, right here it's -2. See, -1 to 0, increase in the oxidation state means oxidation. So in the first reaction, H2O2 is undergoing oxidation. So in the first reaction, H2O2 behaves like the reducing agent. In the second reaction, H2O2 behaves like the oxidizing agent. So H2O2 is the one which can undergo both oxidation as well as reduction, right? In some reactions, it undergoes oxidation. In some reactions, it undergoes reduction. So H2O2 is the one which can behave both as oxidizing as well as a reducing agent. I'm sure it's clear to everyone, right? Perfect. Let me quickly move on to one more question, my dear people. Look here. MnO4 is a good oxidizing agent in different medium. Changing MnO4 negative to Mn dipositive to this. Change in the oxidation state respectively. We need to calculate the change in the oxidation state respectively. Have a look exactly how we are going to tackle this question. If I would want you guys to calculate the oxidation state of this manganese right here, it's going to be +7. Why is that? Let's assume the oxidation state of this manganese is X, right? So it's going to be X plus oxygen will be having oxygen state of -2 normally, and there are 4 oxygen atoms. Net charge is -1, so X value will come out to be +7. So basically, oxidation state of manganese right here is +7. Over here, oxidation state of manganese is +2. Right here, oxidation state of manganese is +6. Right here, oxidation state of manganese is +4. You can check it out. +7 to +2. What is the change in oxidation state? +7 to +2. 5 is the change in the oxidation state. Then +7 to +6. What is the change in oxidation state from +7 to +6? It's 1. 1 is the change in the oxidation state. Then plus 7 to plus 4, 3. 3 is the change in the oxidation state. So it's absolutely going to be option C, which is going to be the correct answer of this particular question as well, right? Perfect. I'm sure this is clear to everyone. So it's absolutely going to be option C, which is the correct answer of this particular question. Okay, calculate the N factor of BaSCN whole twice in the following reaction. We need to calculate the N factor of BaSCN whole twice in this particular reaction. N factor means valency factor. Well, you can only solve this question if you know the structure of your BaSCN whole twice. So let me show it to you once again. This is Ba, this is S, this is C triple bond N, this is S, this is single bond C, this is triple bond N, right? Okay, it's getting converted into BaSO4 and HCN as well. And HCN as well, yeah? Now we will have a look. Have a look exactly. So first thing, the oxidation state of nitrogen right here is going to be -3. It's going to be -3, right? Oxidation state of carbon. See, due to this triple bond, it was going to be +3. Due to this single bond, it's going to be +1, right? So carbon over here has got the oxidation state of +4, right? Even this carbon has got the oxidation state of +4. Few minutes back only, I have shown you this. This has got -2, and this has got -2. Barium right here has got the oxidation state of +2. If you look at this particular compound, BaSO4, in case of BaSO4, the oxidation state of sulfur is +6, right? Well, let's talk about HCN. This is a triple bond, right? So nitrogen -3, at the same time carbon +3. Single bond, carbon -1, right? Hydrogen +1. So oxidation state of this carbon right here is going to be +2, and this nitrogen is going to be -3. So I wrote the oxidation states of all the elements in this particular reaction. Now check out carefully what I'm going to talk about. See guys, barium is showing the oxidation state of +2, right? Sulfur is showing the oxidation state of what? It's showing the oxidation state of -2, right? Carbon is showing the oxidation state of +4, and nitrogen is showing the oxidation state of what? It's showing the oxidation state of -3, right? Now this sulfur over here is showing the oxidation state of +6. This carbon right here is showing the oxidation state of +2, and nitrogen showing the oxidation state of -3. Now exactly we are going to check which element shows increase and decrease in the oxidation state. For which element the oxidation state is changing. Let's check that. See guys, the oxidation state of barium won't be changing. This is dye positive. Over here again barium is in dye positive state, so the oxidation state of barium is not changing. So I've got nothing to do with this barium, right? Now sulfur is showing its oxidation state from -2 to +6. Sulfur is changing its oxidation state from -2 to +6. +6, right? So what is the change in the oxidation state? It's final minus initial. Change comes out to be 8. But this is the change in the oxidation state for one sulfur atom, but I have 2, so 8 2s are 16, right? So the value comes out to be 16, right? -2 to +6, increase in the oxidation state, means oxidation, right? Means oxidation. Similarly, check the oxidation state of carbon. Carbon is changing its oxidation state from +2 to +4. So carbon is undergoing reduction over here, +4 to +2. +4 to +2. What is the change in oxidation state? Final minus initial. The value comes out to be 2. 2 is the change in the oxidation state for one carbon atom, but I have got 2 carbon atoms, so 2 2s are 4. So if this is N1, so I got the N2 value equal to 4. N2 value I got equal to 4, right? Now over here, check it out carefully. The oxidation state of sulfur is increasing and that of carbon is decreasing, right? Whenever you'll be having such a compound in which oxidation state of one element increases and another one decreases, how do you calculate its overall N factor? Its overall N factor is going to be mod of N1 minus N2, right? So N1 value we have calculated, that's 16. N2 is 4, so the value comes out to be 12. So you got to know exactly for BaSCN whole twice, the N factor is exactly going to be 12. You can let me know carefully in the chats if it is clear to everyone, right? Let me know fast in the chats, my dear people, if it is clear to every single guy. Yeah, perfect. So do remember basically whenever in a compound, oxidation state of one element increases and another one decreases. At that point of time, we calculate the overall N factor of that compound by the formula mod of N1 minus N2. And do remember, whenever you see such kind of a compound in which oxidation state of two elements simultaneously either increases or decreases, at that point, how do we calculate the N factor of that compound? It's going to be mod of N1 plus N2. Do remember that, right? Perfect. Let's move on, people. Let's move on. Calculate the N factor of P4 in this particular reaction. This is a particular reaction which is given to us. We need to calculate the N factor of P4 in this particular reaction. Let's have a look exactly how it's to be calculated. First thing, I'll be writing the reaction again. This is P4. It's basically getting converted into PH3, and with this PH3 you are writing H2PO2 negative, right? This is the reaction which you are writing over here, right? Now people, if I ask you what about the oxidation state of phosphorus right here, it's going to be 0. Oxidation state of phosphorus right here, it's going to be -3. Oxidation state of phosphorus over here, how much it's going to be? It's going to be 2x, right? 2x, sorry, not 2x. Hydrogen shows the oxidation state of +1. There are 2 hydrogens attached. Phosphorus shows the oxidation state of X, right? Oxygen shows oxidation state of -2. There are 2 oxygen atoms. The net charge is -1, right? So this is going to be +2 plus X minus 4 is equal to -1. So it's going to be X minus 2 is equal to -1. So the X value comes out to be +1. So the oxidation state of this phosphorus is +1, right? Now we will check it out carefully. Phosphorus over here shows decrease in the oxidation state, right? And again, as you can see over here, phosphorus in this particular one shows increase in the oxidation state. So the same element is undergoing oxidation and reduction. So I must say this P4 undergoes disproportionation. This P4 undergoes disproportionation. And whenever you need to calculate the N factor of a species which undergoes disproportionation, how do you do that? The overall N factor of this particular P4 is going to be N1, N2 divided by N1 plus N2. This is going to be one of the simplest formulas by means of which you'll be calculating the N factor of the species which undergoes oxidation as well as reduction, or I can say which undergoes disproportionation. Yeah. Now check it out. 0 to +3. What is the change in oxidation state? 0 to +3. 3. 3 is the change in the oxidation state. But do remember, 3 is the change in the oxidation state for 1 atom of phosphorus. But I have 4 atoms of phosphorus, so 4 3s are 12. So N1 value is equal to 12. Right? Now check it out. 0 to +1. Change in the oxidation state, 0 to +1, that is 1. 1 is the change in the oxidation state for 1 atom of phosphorus, but I have 4. So N2 value comes out to be 4 exactly. So N1 you got, N2 you got. So N1 multiplied by N2 divided by N1 plus N2. So it comes out to be 48 divided by 16, and 48 divided by 16 comes out to be 3. So I must say in this particular reaction, the N factor of P4 is simply going to be 3, right? As simple as that. Well, if you got the N factor of P4, you can easily calculate its equivalent mass as well. Molar mass of the compound divided by N factor of the compound. Perfect. I'm sure you can easily solve these sort of questions. Look here, my dear people. In this particular reaction, have a look. You have got N2H4, and this N2H4 is getting converted into HNO3, right? First thing, I will be calculating the oxidation state of this nitrogen and this nitrogen over here. Let's get to know that. Have a look. Let's assume the oxidation state of this nitrogen is X, so it becomes +2X, right? Sorry, 2X. Hydrogen shows +1, and there are 4 hydrogen atoms attached. Net charge is 0, so X value will simply come out to be -2. So nitrogen over here has got the oxidation state of -2, right? If you look at this particular nitrogen, my dear people, this nitrogen will have the oxidation state of +5 when you calculate it. Right? Now check. The oxidation state of nitrogen is increasing. Increase in the oxidation means oxidation. So this particular compound right here is undergoing oxidation. Now we will have a look. I need to calculate the N factor. N factor of this N2H4, right? It's simply going to be equal to change in the oxidation state, which is final oxidation state minus initial oxidation state. The value comes out to be 7. But this 7 is the change in the oxidation state for 1 atom of nitrogen. But I have 2 atoms, so 7 multiplied by 2 comes out to be 14. So I must say, in this particular compound, N2H4 has got the N factor of 14, right? If you got the N factor of this particular compound, you can easily calculate its equivalent mass as well. How come? Molar mass of the compound divided by its N factor. That's all, right? I'm sure you can easily solve these sort of questions. Wait. What? Is the oxidation state of nitrogen over here is +3 or +5? Let me check it once again. HNO3. Hydrogen shows +1. Nitrogen shows X, right? Oxygen shows -2. 3 oxygen atoms. Net charge is 0, right? So it's going to be +1 plus X minus 6 is equal to 0. No, X is +5. This is wrong given here. The correct answer is going to be 14, right? The correct answer is going to be 14. Perfect. Let's move on. All right. Calculate the N factor of ferrous oxalate, right? This is ferrous oxalate which is given to us. Let's calculate its N factor. See guys, this is Fe, this is C2, this is O4. It's getting converted into Fe tri positive. With this you are going to write carbon dioxide. This is the reaction that's given to me, right? What do I need to calculate? I need to calculate the N factor of this particular species over here, right? See, this is basically your oxalate ion. Oxalate ion always has -2 charge, so iron will have +2. The oxidation state of iron is +2. When you calculate the oxidation state of this carbon over here, it comes out to be +3. When you calculate it normally, right? +2 plus 2x minus 8 is equal to 0, so x value will come out to be +3. The oxidation state of this iron right here is +3, and the oxidation state of this carbon over here is going to be +4. Now check. Is the oxidation state of iron increasing or decreasing? Increasing. Is the oxidation state of carbon increasing or decreasing? Again increasing. So basically, I got to know this is the compound in which the oxidation state of two elements simultaneously is increasing, right? How do I calculate its N factor? It's going to be mod of N1 plus N2. Yeah? Have a look. So first thing, check for iron. +2 to +3. What is the change? 1 is the change. So N1 value is 1, right? +3 to +4, what is the change? 1 is the change, but 1 is the change in the oxidation state for one carbon, but I have 2, so 1 into 2 comes out to be 2, so N2 value comes out to be 2. So I got N1, I got N2, and already I told you, this is basically the compound in which oxidation state of two elements simultaneously increases. And how do we calculate its N factor? It's going to be mod of N1 plus N2, right? So N1 plus N2, N1 value will come out to be, N1 value comes out to be 1, N2 comes out to be 2, so 1 plus 2 comes out to be 3. So you got to know exactly the N factor of this particular compound is 3, so it's option C, which is the correct answer of this particular question. I'm sure this is again clear to everyone, right? Perfect, guys. So this is something which you can do now on your own, I'm sure about that, right? Do give it a try. Do give it a try. It is a similar sort of question. N1 plus N2 you have to use and get the answer, right? This is something which we have done few minutes back. This is something which we have done few minutes back. All right, balance the following reaction in acidic medium. We need to balance this particular reaction, right? See guys, have a look. We have got many methods by means of which we can balance the particular reaction, right? The simplest among all is oxidation number method. The simplest among all is oxidation number method. And how do we balance the reactions in acidic medium with the help of oxidation number method? Let's check out that. See guys, let me calculate the oxidation state of this manganese, it's +7, this iodine it's -1, this manganese it's +2, and this iodine it's 0, right? I would first of all calculate the N factor of MnO4 negative and I negative over here. Check it out, +7 to +2, change in the oxidation state is 5, so I must say its N factor is 5. -1 to 0, change in the oxidation state is 1, so its N factor is 1, right? After calculating the N factors, what I would want you guys to do, just crisscross these N factors. Make this 1 as the stoichiometric coefficient here, make this 5 as the stoichiometric coefficient here, right? Well, after crisscrossing the N factors, let's try to balance all the atoms except hydrogen and oxygen. Have a look, 1 manganese, 5 iodines and 2 iodines. So let me make it 5 divided by 2 times. Now iodine are balanced. I balanced all the atoms except hydrogen and oxygen, right? I did that. Now after that, since the reaction is taking place in the acidic medium, after balancing all the atoms except hydrogen and oxygen in the acidic medium, we balance oxygen with the help of water. How do we do that? See, we have got 4 oxygen atoms on left hand side. On right hand side there is no oxygen. In order to balance oxygen, we add water molecules on that side which is oxygen deficient. Which side is oxygen deficient? It's right hand side. And how many oxygen deficiencies is on right hand side? 4 oxygen deficiencies on right hand side. So I'll be adding 4 water molecules on this side. So now oxygen is balanced, right? Now after balancing the oxygen, you need to balance the hydrogens now. And hydrogens are to be balanced with the help of H positives. Have a look. On right hand side there are 8 hydrogens. On left hand side there is no hydrogen. So I'll be adding 8 H positives on that side which was hydrogen deficient. Now it's a complete balanced chemical equation. You did not check it again. Now it's a complete balanced chemical equation, right? Yes. Or you can just convert it into one more form. Since this is 5 by 2, if you do not want this to be in fraction, so I would want you guys to multiply throughout with this 2 over here, then it becomes 2 times MnO4 negative, 2 times MnO4 negative, plus 10 times I negative, plus 16 times H positive, it gives 2 times Mn di positive, and it gives 5 times I2. With this you write 8 times water as well. This is one more way of writing the balanced chemical equation. The choice is all yours, right? Perfect. All right, people. So let's move on. Let's try to see a few more things. Calculate the number of gram equivalents in 50 ml of 0.5 normal NaOH aqueous solution. See, I hope you remember How do we define normality? Normality is basically number of gram equivalents of solute, right? Number of gram equivalents of solute divided by, if I write volume of solution in milliliters, then I'll be multiplying it with 1000 over here. This is one quick result for normality, right? Number of gram equivalents of solute, volume of solution in milliliters multiplied with 1000, right? Yes? Now we will have a look. What do I need to calculate? I need to calculate gram equivalents of what? Gram equivalents of NaOH. So I need to calculate the gram equivalents of solute. Boss, the question is done. The question is done. So you can calculate gram equivalents of solute. Gram equivalents of solute is simply going to be equal to what? It's going to be normality multiplied by volume of solution in milliliters divided by 1000, right? Divided by 1000. Normality is given to us as 0.5. Volume of the solution in ml is given to us as 50 divided by 1000. Solve it. That's going to give you the number of gram equivalents of NaOH in the solution, which you were supposed to calculate, right? I'm sure it's clear. Perfect. All right, this is one more particular type of question based on the redox titration. See guys, how this sort of a question is to be solved. The question says, what volume of 0.1 molar KMnO4? What volume of 0.1 molar KMnO4 is required to oxidize 100 ml of 0.3 molar FeC2O4? FeC2O4, right? See guys, how am I going to do it? Let me give this as number 1. Let me give this as number 2. First of all, you should know the N factors in the acidic medium. Do remember, N factor of KMnO4 in acidic medium, I'm sure you guys know it, that's 5. N factor of ferrous oxalate, few minutes back only we calculated that, right? That came out to be 3, right? That came out to be 3. Few minutes back only we solved. Perfect, number 1. Number 2, we need to calculate the V1 value, volume of KMnO4. Molarity of KMnO4 is given to us how much? 0.1, right? Well, the molarity of ferrous oxalate is given to us as 0.3. Its volume is again given to us as 100 ml. So how am I going to solve this question? Simple, you are going to use the concept of milli equivalents over here. You'll just equate their milli equivalents, that's all. I'll clearly say something like this. I'll write milli equivalents of one reactant should be equal to the milli equivalents of second reactant. And how do we get the milli equivalents? Normality of first multiplied by volume of first in milliliters. This formula gives you the milli equivalents, right, of solute. And if you talk about the milli equivalents of second, it's going to be N2 multiplied by V2 in ml. Now people, what is normality basically? As per the formula, normality is nothing, it is molarity multiplied by N factor. So normality of 1 I can write as molarity of 1 multiplied by N factor of 1, then there comes V1 in ml. Normality of second is going to be molarity of second multiplied by N factor of second, and it's going to be V2 in ml. Now all the parameters I guess are given to us. M1 value. M1 value is given to us as 0.1. N factor of 1 is 5. V1 I need to calculate. V1 I need to calculate is equal to M2. M2 is given to us as 0.3. N factor of 2 is 3. V2 is given to us as 100. So from this particular equation, you can easily calculate V1 from here. And what was V1 exactly? V1 was the volume of KMnO4 which was needed basically as per the equation, right? So the correct answer after solving this particular equation comes out to be 180 milliliters, right? Perfect guys. Exactly. Let's have a quick look on one more question. There's one more similar sort of question. See how am I going to solve this one. Have a look. Or let me show you directly its solution. See. What volume of 0.1 molar K2Cr2O7 is required to oxidize 50 ml of 0.2 molar Cu2S? First thing, I'm sure you know their N factors in acidic mediums. N factor of K2Cr2O7 in acidic medium is 6. This is 8, right? So what I'll be doing exactly? This is not equaled. Just a second. This is not equaled. This is not equal, right? So first of all, I'll be calculating the normality of first, normality of this one, then I'll be calculating the normality of second one, normality of this particular solution. Well, let me tell you, normality of K2Cr2O7 is equal to molarity of K2Cr2O7 multiplied by N factor of K2Cr2O7, right? This is, molarity is given, its N factor is 6, so molarity is 0.1, N factor is 6, so the normality of this particular solution comes out to be 0.6. In the similar way, normality of this particular solution comes out to be 1.6, right? Well, after getting the normalities, just equate their milli equivalents. Milli equivalents of first should be equal to milli equivalents of second. Using the formula, get the volume over here, which comes out to be 133.33 ml, right? It's one simple question again, based on the same concept which I told you a few minutes back only, right? Okay, if you look at this particular one, this is the similar sort of question, my dear people. Right now, you are making KMnO4 to react with what? you're making KMnO4 to react with ferric oxalate. That too in acidic medium, right? You're making them react. Let's say normality of KMnO4 is N1, right? Volume of KMnO4 is given to us as 100 ml. Perfect. Well, molarity of ferric oxalate is given to us, I believe, 0.2. And let me tell you, N factor of ferric oxalate is equal to 6 is in acidic medium. And volume of this ferric oxalate is nothing, that's 200 ml. So first thing, I'll be calculating normality of first, which is equal to molarity of first multiplied by N factor of, sorry, this is second, right? This is second. I'm representing this by number 2. And this is something which I represent with number 1. So normality of second comes out to be molarity of second multiplied by N factor of second. So it comes out to be 1.2. I'll be just equating their milliequivalents, right? I'll say milliequivalents of first, that is N1 multiplied by V1 in ml must be equal to N2 multiplied by V2 in ml. Say guys, normality of first I need to calculate. That means normality of KMnO4 I need to calculate. Volume of KMnO4 is given to us as 100 ml. Normality of second is nothing, that's 1.2. And volume of second is nothing, that's 200 ml. So from here, you exactly get the N1 value, which comes out to be 2.4, right? So option A is going to be the correct answer of this particular question, right? Perfect. Just equating their milliequivalents, that's it. That's all. And that's all, my dear people, for the tonight's session. I'm sure you would have enjoyed it. And if you will be having any sort of difficulty in understanding anything in this particular session, just write that in the comment section of the video. And for the NEET as well as JEE students, today on the actual Vedantu platform, we have launched fresh crash course batches for NEET English, JEE English and JEE English students, right? So basically we have launched 4 crash course batches. If you want to go for NEET English batch, or JEE English batch, or NEET English batch, or JEE English batch, you can join it. It's going to be completely affordable. Your whole syllabus of your physics, chemistry, zoology, botany, maths in all the batches is going to get covered before examination. Not only about the syllabus completion, it is going to be the syllabus completion starting from the scratch, starting from the basics. So in 120 sessions, your whole syllabus of your NEET as well as JEE will be getting covered in 2 different batches, right? Okay, and it's not only about the syllabus completion over here. You'll be getting the test series as well. In this crash course, you'll be getting 10 part tests and 10 full tests, my dear people, right? And you'll be getting the liberty to watch the recordings of the sessions till your NEET 2022 examination as well, right? So this is completely going to be beneficial for all of you, right? And I personally will be taking some of the important chapters in JEE English batch as well as NEET English batch, right? So do get enrolled in it as soon as possible because the batch started today on the actual Vedantu platform. And let me quickly show you how to get enrolled into this particular batch. But before that, let me show you a few important things. This is the Telegram group link. You can join this. Right? Okay, because we keep on sharing the important things on this Telegram group itself, right? Okay, this is the video which you guys are currently watching, right? If you want to get enrolled into the batch which I was talking about, you need to drag this video a little down, which you are currently watching, click on show more. After clicking on show more, you can now go for any of the crash courses. If you want to go for NEET crash course, click on this. If you want to go for JEE crash course, click on this link. And in both the crash course batches which got started today on the actual Vedantu platform, your master teachers, they'll be starting exactly from the basics, my dear people. Covering the basics first, right? Covering all the theory in all the chapters, then doing all the problem patterns, then assignments will be also provided to you, which you will be solving, by means of which you get to know about your weaknesses as well, right? So do get enrolled as soon as possible. This is my personal suggestion for you guys, because by enrolling into these crash course batches, definitely you're going to kill it, right? For example, you're going for NEET crash course. I'm clicking on this link, right? Just drag a little down, click on buy course, and after clicking on buy course, you can put your number, email ID on which you get the OTP and everything, and eventually you'll be getting enrolled into the batch which I'm talking about, which started today on the actual Vedantu platform, right? I'll quickly show you one more thing. See guys, if you want to have a look on the course overview, you're getting basically 120 sessions. In just 120 sessions, your whole syllabus is going to get covered. 10 part tests you are getting in this, 10 full tests you are getting, and this is the test series which has been designed by the best teachers of Vedantu who have got the teaching experience of more than 25 years, my dear people. Apart from that, you'll be getting 500 plus practice quizzes. Live doubt solving will be there. That means during the session, if you face any sort of difficulty in understanding, you can ask your doubt directly to your master teachers, right? And at the same time, as I told you, assignments will be provided to you, 90 plus assignments, right? Which are going to make you exam friendly already. So this is the specially designed course, right? This is the specially designed course for NEET as well as JEE students, right? The batch started today on the actual Vedantu platform, and a lot of students are asking, sir, are you taking the classes? Yes, I'll be taking the classes, but not all the chapters of chemistry I'll be taking some of the important chapters of chemistry, right? For example, I'll be taking care of equilibrium, thermodynamics, right? Chapters like that, GOC, isomerism, right? And I've got 2 more teachers with me. They'll be taking care of the rest of the chemistry, right? So do get enrolled as soon as possible, right? It's going to be beneficial. The batch started today only, right? And your whole syllabus, starting from the basics, is going to get covered over here. So if you have not started your preparation yet, or if it's not up to the mark, this is the best thing which you can have right now. Do get enrolled as soon as possible. See you in the crash course batch. Till then, take care. God bless you all and love you all. Bye-bye.